Hi, today we are here to present the concept and implementation of web search engine. So let's start with what is web search engine. So everyone who uses the internet operations would have used at least one of the web search engines like Google, Yahoo, Bing, or any other web search engine. So even the video you are watching right now probably is crawled and brought to you by any of the search engine. As its name suggests, search engine is a software system that performs the web searches. It conducts a systematic search of word in World Wide Web for specific information specified in a textual web search query and display the best output result to the users. So how it is done actually? So for that many concepts are being used. So one of them is web crawling. So web crawling is the technique used by search engine to collect the information from the internet, and this collected information is stored and analyzed into the database. When user enters the query, it is generally few words. These words will be searched against the indexed database which is already stored, and final output result will be displayed to the users. As just explained, working flow of search engine starts with crawling, following by analysis and indexing, and lastly ranking algorithms. Ranking algorithms will send the query and fetch the result from sorted indexing and display the best output to the users. We have used following concepts in our web search engine implementations: regular expressions to find the URLs, hash table to store those URLs uniquely, Boyer-Murray algorithm to find or search any words into stored indexed databases, edit distance algorithm to suggest any words, and sorting algorithm to finally sort the results. Now let's go through the flow and functionality of our search engine and see what all operations are being performed at each stage. So when search engine starts, we have provided multiple options to the user. In one option, user would be able to search the word from pre-entered URL, which is already crawled and stored into the database. And in other option, user would be able to enter the URL of their own choice. So if user select the second option and wants to enter the URL of their own choice, that URL will be validated first. If that URL is working correctly, then it will go to the next stage, web crawling. If it is not working correctly, then user will be prompted to re-enter the URL. So after validating successfully that URL, we will be going to next step, web crawling. In web crawling, we have implemented the concept of Java regex to find the sub URLs on the page, and all the sub URLs or all the URLs will be stored uniquely into hash tables. The next step is to parse the URL and convert the HTML file to the text file formats. And all these HTML and text files will be stored into predefined locations. So once parsing and conversion is completed, user will be prompted to search the word of their own choice. And we have incorporated Boyer-Murray search algorithm for this operation. If the entered word found into the database, list of URL in which the word occurred will be displayed with the frequency count of the occurrence, and at the end top 5 results will be displayed at the final result. But if the word does not occur or could not be found into the database, then similar word suggestions would be displayed to the user. We have incorporated edit distance algorithm for this, and we have kept edit distance of 1. Now let's go through the each functionality in detail. So first one is web crawler. So web crawler is also known as a spider or spider bot, which browse the content for indexing purpose. So web crawler begins the search with list of URLs to visit. This URL also known as a seeds, and the crawler visit each URL recursively and find all the sub URLs on the page available. Now let's go through the implementation part, how we have implemented web crawler in our project. But before we get into the implementation part, let's go through some of the terminologies we have used. The first one is regex. So regex or regular expression is a sequence of characters that specify the search patterns. The another one is crawl depth. Crawl depth refers to the extent to which search engine indexes the site's content. Most of the site contains multiple pages, which can contain another multiple sub-pages. These pages and sub-pages goes deeper into the manner that the way folders and subfolders in our computer system. So sites home pages by default of crawl depth of 1, crawl depth of 0, and all the pages directly linked to the home page has by default crawl depth of 1, and all the other sub pages are linked directly to the web pages of depth 1 have by default crawled depth of 2, and so on. In our implementation, we have set the value of 2 for our crawl depth. To avoid the duplication in stored URL, we are using hasset in our implementation. And to find the pattern URL, we have created hash strings, and we will be using compile string method of pattern class to find this URL. There is a method in place to verify the correctness of URL. This method will eliminate the strings found as a matched in pattern.compile_string method but are not genuine URL. So now I would like to ask Dhanraj to take over from here and explain further more about HTML to text conversion.
Thanks, Dipen. In our search engine, second feature is HTML to text. The process of extracting data from crawled HTML files and storing it in text format is known as HTML to text conversion. These text format files are then used to perform word search in the search engine. JSoup is a Java library that is primarily used to work with real-world HTML. It provides a very user-friendly API for retrieving URLs as well as extracting and manipulating data using HTML5 DOM methods and CSS selectors. JSoup basically implements the WhatWG HTML5 specification and parses HTML to the same DOM as modern browsers. Talk about implementation. In the project, we have implemented two methods. The first is to save the HTML files into the system, and the second is to convert the HTML files into text format and store it into the system. The HTML files or documents are first retrieved from the fixed path, then converted, and finally saved into the system. The method then converts the HTML file to a text file, which are saved in a separate location on the given path in the system. These stored text files will be searched to find any word in the search engine as a database. We have provided a link that runs all of the operations on predefined data. However, users can enter their URLs of their choice and perform all the operations. So now further lead will be taken by my teammate Pranav.
Thank you, Dhanraj. So now let's talk about a pattern matching. We used a regular expression in our project, which is also known as Java regex. A regular expression is a sequence of characters that define a search pattern, mainly for use in pattern matching. The pattern is used here to ensure that only website URL found within the provided regex are passed, and any website found outside the provided regex are not passed. It is an important tool to manipulate text as well as used in automated generated web page. Regular expression either match text or fail. So, if the regular expression matches the part of text, then it is easy to identify that particular path. Sometimes, when regular expressions are complex, at that time you can easily find out which path can match with other parts of the text, so that it becomes easy to extract or substitute that particular path of the text. Example of different applications where pattern matching is used: parser, span filters, digital libraries, computational molecular biology, screen scanners, NLP, which is also known as natural language processing, word processor, and finally, web search engines. Now let's talk about the implementation part. To import java.util.regex is necessary to use regular expression, and it is compulsory to compile the pattern, which you can see in the example. Now take other example to understand how pattern works. If one pattern is followed by another, the two patterns must match consequently. You can see in the example, if you use this pattern, it will match one or more letters followed by one digit. In vertical bar, this symbol is used to separate alternatives for this pattern. It will match either A, B, C or X, Y, Z. Other different type of patterns. First pattern is used exactly this sequence of 3 characters. Second pattern is used for any one of the character A, B or C. Next one is for any character except one of the letter A, B or C. This symbol means not to use that character. Next pattern is for any character from A to Z. Same as the last one for any one character or a digit. Now I request my friend Bansri to continue and explain web search feature.
Thanks, Pranav. Word search is one of the most important feature of search engine. It is implemented using string searching algorithm or string matching algorithm. There are various string searching algorithm like naive string search algorithm, brute force match, Bohr-Moore algorithm, and Knuth-Morris-Pratt algorithm, which is also known as KMP algorithm. We have used Bohr-Moore algorithm in our search engine because it searches the word by character comparison at different alignments and skips the unwanted alignments. Whereas the brute force match algorithm uses all the alignments and it does not skip the unnecessary alignments. Bohr-Moore algorithm uses the pre-processing step which allows to skip as many alignments as possible. Moreover, BM algorithm also works well for long strings, which is why we have used it here. Now, let us see the example of Bohr-Moore algorithm. Here, welcome to algo is the text and to al is the word to be searched. In pre-processing step, the pattern will be scanned from right to left, pointing to the last character of the word. Here we will be using bad character rule. So the character of the text that does not matches the current character of the word will be known as the bad character. In our case, T does not match L, so T is the bad character. Now we will look for the occurrence of bad character in the word, and if found we will shift the word such that it is aligned to the mismatch character, and now mismatch becomes match, that is T becomes equals to T. Now again we will compare the characters. Here the bad character is E and now we search for E in word. And if it is not found, we will shift the word past the mismatching character. That is, we will shift the alignment to T. Now again, we will compare each character and if every character matches, then the index of the pattern will be returned. This is how the Bohr-Moore algorithm works. Now, let us discuss the time complexity of Bohr-Moore algorithm. In best case, the Bohr-Moore algorithm takes OM time for pre-processing and O of n upon m time for searching. Whereas in worst case, Bohr-Moore algorithm takes OM time for pre-processing and O of n into m time for searching. Now, let us see how we have implemented Bohr-Moore algorithm in our search engine. As discussed, Bohr-Moore algorithm uses two steps. The pre-processing of the pattern is necessary in the algorithm. In this step, the pattern is scanned from right to left for the position of the rightmost character. And in searching step, if the given word is found in the text, then the index or the offset of the word is returned. And if the word searched is not present, then the length n of the text is returned to the calling function. For every occurrence of the word, counter variable is incremented by 1 to find the total number of occurrences of the word in the text. Now, I would like to pass it over to Helly for word suggestion function. Thank you.
Thank you, Bansri. Now we will discuss another feature of a web search engine, which is the spell autocorrect feature. It is also known as the alternate word suggestion. It is a popular search feature which is available on almost all the web search engines. If a user misspells a word or enters one that does not exist, the engine will then suggest the most similar word to that. Normally, Google does this functionality by validating the typed keywords against the dictionary. If it doesn't find that keyword in the dictionary, it suggests the most likely replacement for the typed word. We have used a similar approach for our web search engine using the edit distance algorithm. Edit distance algorithms are used in the natural language processing. It is used where automatic spelling correction can determine the candidate correction for a misspelled word by selecting the words from the dictionary that are close to the misspelled word. There are three minimum number of operations which are required to transform one string into another using the edit distance algorithm. They are first, removal, second, insertion, third, substitution of a character in a string. The terms Levential distance and edit distance are frequently used interchangeably. To do this, we have associated every word a frequency, that is, the number of times a word appears in the search URL. When a word is misspelled or say not found, then the system will suggest a similar word whose frequency is larger or equal to the typed word. There are three rules that determine how a word is considered to be most similar. First, it should have the closest edit distance from the input string. Second, if there are multiple words with the same edit distance, then the most similar word is the one word that is found most number of times in the dictionary. Third, if multiple words are of the same edit distance and have the same count of the frequency, then the most similar word is the one that appears first alphabet. No two words with a maximum edit distance of the two are found. Then a message will be displayed to the user stating the same. Thank you. That was all from my part. And now I would like to ask Manan to carry forward with the remaining presentation.
Thank you, Haley. So now we'll talk about the page ranking system. PageRank is an algorithm used by Google Search to rank websites in their search engine results. PageRank works by counting the number and quality of links to a page to determine a rough estimate of how relevant the website is. The PageRank computations require several passes called iterations through the collection to adjust approximate PageRank values to more closely reflect the theoretical true value. Now we'll take an example to understand how ranking works. In the image given above, page B has higher rank than page C due to the frequency of word search. Similarly, page C has higher rank than page E, even though it has a fewer links. The one link to C comes from an important page, so it is of high value. On the other hand, page A, D, and F has lower page rank as they have low frequency of word search. Now we'll talk about the implementation part that we have used here. Sorting is a critical component of a search engine that is used to rank pages. We use the merge sort strategy to rank pages in our project. To begin, all web pages will be scanned for indexing. After scanning, indexing of all web pages where the discovered word appears based on frequency is performed. The web pages are sorted using Java's collections process, which employs the merge sort algorithm by default. In our implementation, we'll only show the user our top 5 results for search in terms of page ranking. Thank you for considering and taking out time for the presentation. Now we'll show you a demo that how our search engine works.
Thank you, Manan. As we have seen already, the implementation and concept of our search engine and how we have implemented. So now let's go through working demo of our search engine developed. So let's start with it. So we have provided three options to user as we have discussed already. So if user press 3, so directly user will exit from the search engine. In another option, we have provided user to search from predefined URL. In our case, it is University of uvinsert.ca. So if user presses 2, then by default that link will be crawled and user will be able to search from those. So let's go ahead and see. So these links are being crawled and stored into hash tables. In our case, we have set crawl depth of 2. So links will be crawled and searched till depth 2. So once crawling is completed, user will be prompted to enter the word he or she wants to search. So let's go ahead with that and see if this word is present or not. So there is one URL which consists of these words. So then after user will be able to search another word if they want. So let's go ahead and search another word, research. So if there are multiple links, then top 5 results will be shown to user in which the most frequently that word occurred. So at any time if user misspelled or incorrectly entered some word, then algorithm will suggest another word, most similar word to user. So let's see that if I'm entering this word, then most similar and closest word to that will be suggested to user. And if user wants to return to main menu anytime and user wants to search his or her own URL, then user can directly enter his or her own URL by pressing 1. So here user will be prompted to enter valid URL. An example of valid URL is given in which format the URL should be. So if I'm incorrectly entering any URL, then it will be validated first. If that is not working correctly, then this error message will be shown, this URL is not valid, please try again. And if I'm pressing 1 ahead and I am entering any URL which is working correctly and fine, then user will be able to search from that. So let's see that we have entered this URL which is correctly fine and working. So it will be validated, and if it is valid, in our case it is valid, then crawling will start. And the similar manner we have seen, user will be able to search all the words from this and perform all the operations whichever we have seen in the option 2 predefined URL option. So if user wants to close at any time, then they can go ahead directly and they can exit the search engine. This is the search engine we have developed, and these are